Hello, everyone. Welcome to episode 71 of Reconstructing Case Story. Today, we're just going to be upgrading to SDL 2.0. It's not, honestly, I don't think it's a very interesting episode because it's like the code's going to do the same thing at the end of this. So, if you don't feel like doing this, it's probably not a big deal if you don't want to do it. But there will be some different calls, maybe in graphics and in input, especially where we will have some changes. So, yeah, the reason we're using SDL2, a lot of people have been asking me to use it, and I've been planning on switching over to it because it's got some nice benefits to it. So like scaling textures for setting screen size is going to be really nice. In SDL 1.2, there's no functions for actually scaling the textures. And also we'll get OpenGL rendering in the background for free. We won't have to switch over from software to hardware performance later. For performance reasons later. It'll just happen for us. STL does it under the hood. And then we'll also be able to use scan codes instead of key codes. And what a scan code is it's just a positional code for your keyboard. So let's say if you're using Dvorak or some Hungarian keyboard or German keyboard or something, your WASD will just be those three keys over on the left. And so that'll be pretty nice for not having to worry about keyboard layouts and stuff like that. So those are going to be the major changes. Also, just want to go over real quick in graphics, what SDL2 does is introduce some new abstractions over some of the older abstractions. So it's just another layer just so that they could combine, I think, their 3D stuff and their 2D stuff and do some other things with that. So some of the major changes are in graphics, but also the scan codes in the input that we'll want to switch over to those too. So the window is another layer over abstraction over the screen. So instead of calling SDL set video mode, we're going to be calling SDL create window, which actually is kind of a nice change because that makes a lot more sense than set video mode, whatever anachronistic reason that exists for. So this is going to replace our SDL surface screen. We'll no longer have one of those, but instead we'll have a pointer to the window. Then also there's an SDL renderer, which is a layer of abstraction over SDL's process of drawing. So this has to do with, whether you're using OpenGL or just drawing like for its 3D stuff or drawing to 2D graphics. So this provides a layer of abstraction over that kind of thing. So it's going to replace a lot of our draw calls let's see, SDL render copy instead of SDL blitz surface is one. And, I can't remember all of them, but for things like clearing the screen too, we're going to have SDL render calls for that too as well. And finally, we have texture, which is just a layer of abstraction over SDL surfaces. And that's literally we're just going to call this function in order to translate it from a surface to a texture. So none of this is any big deal, and it's not very interesting. This probably won't take that long. The hardest part is setting things up in Windows, and if you're not using Windows, then it's the easiest thing in the world. So I did a little bit of some work behind the scenes. I went ahead and downloaded SDL version 2.0.3. If you go down here to development libraries for Windows, you can download this, and that's what we're using. For Linux and for Mac, it's pretty easy. You get all that done for you. So anyway, if you open up that, it'll just be a zip file with this single folder in. Let's see, let me open up Cave Story and show you guys where I stuffed it. So let's see, I put it inside of the Cave Story / Cave Story folder right here alongside of SDL 1.2.15. I'm just gonna leave that in there for now. It doesn't really bother me that it's there. I could delete it, but I'm not going to. And then finally, let's see, what else did I do? This is all taken care of in the make file. If you're running Mac or Linux, I'm going to update that for the GitHub repo. It should work for both, but you're gonna have to do some stuff for the Windows version. So if you go into not configuration properties, cave story, there it is, configuration properties. I think I had inside of the include directories, I had SDL 1.2. Let's see, edit. Yeah, and I'm gonna get rid of that. So that's gone. And then library directories, SDL 1.2, gonna get rid of that. And there's actually a better place to put these, which is the additional include directories. And so I went ahead and added, let's look at it. I added the SDL 2.03 include file or folder. Added that to the additional include directories, which I guess is the right place to put it. I don't know for sure. Let's see. Then in the linker, there's additional libraries directories, and I added the lib x86 because I'm compiling for 32-bit mode, just to make things easier on me, I guess, somehow. And the input now changes to SDL2.lib and SDL2 main.lib to match the files inside of the lib directory x86. So that's you telling the SDL2.lib and SDL2 main.lib. That's what you're saying. Hey, I want to use those. And then I went in and copied the DLL file into the directory where we're running from. So that's up at the top level cave story, the first cave story inside of debug, and that's where we're executing from. So right next to our SDL.dll, I dropped in SDL2.dll. So that's just what I changed behind the scenes. I figured there'd be a lot of drag and dropping, and I didn't want to mess it up while I was talking. So I did it behind the scenes. Nothing too interesting though. There's a whole video. I have a video that I'll link in the description about how I set up SDL 1.2 because it is a pain on Windows to set up. All you have to do on Linux is just change it from SDL package config or whatever to SDL2 package config, and then it's done, which is really nice. Okay, so one of the things I just did behind your back is actually change the include directory. So now we're, instead of, let's see, let me just open up an example, main.cc. So instead of including SDL/SDL.h, we're just going to do SDL.h. I figured out the right way to do that on Linux. It's part of just writing the makefile a little bit differently. So I thought it was a big deal before, and I guess I was wrong. And now is a good time to fix it. So we'll just go and grep, or not grep. We'll use the solution find and replace. If you're running Linux or Mac, you'll probably want to grep. But I'm going to do find, I think it's in the edit menu. Find and replace in files. Find in files. Look at an entire solution. We want to find SDL/SDL.h. Find next. We'll just change all these and worry about the bugs a little bit later. Sprite.h. Backdrop. Oops. And it's nice because I know exactly where I'm using SDL2 when I do it this way. Graphics and looks like sprite and backdrop too. All right, so that's all done. Now let's jump into graphics.h and start making those changes I said. So instead of having a screen pointer, we'll have a window pointer and a renderer pointer. And I'll bring up some of the documentation when I start doing this. We're no longer going to need to use SDL surfaces. These will be replaced with SDL textures. So I'm going to do that for our surface ID, as well as our map, our sprite map will be of SDL textures. We'll get rid of our screen pointer. And instead, we will have a window and a renderer. Let's see. Yeah, there we go. So again, those are all forward declared. Now it's time to define them. So let's go into graphics and get rid of our SDL set video mode call. And instead, we're going to be calling it with, we're going to be calling SDL create window. And so it's actually kind of nice. If you look at the SDL create renderer documentation in wiki.libsdl.org, it actually gives you a sample of how to create it. So what they do is they create a window first, and then they create a render with the default renderer stuff. So let's start with creating our window. It takes in a title, an X and a Y. We can just use window pause undefined if we don't care. And then the width and the height, we're already passing those in as screen widths and screen height, as well as some flags. So let's look at the flags. We don't want it full screen. I don't think we want to use OpenGL. I'm not going to think about that right now. I'm just going to get it to work right now. And then, so definitely don't want it hidden. We don't care if it's borderless. We don't want it resizable, so we don't pass it in. So basically, we're not going to pass anything in, so we'll just pass 0 instead. So let's do that. So let's say our window is equal to SDL create window, and it takes in a title. So let's pass in Reconstruct Cave Story. And again, I said SDL window pause undefined. So we'll pass that for our X and Y position. We don't really care where it ends up on the screen. We can do centered if we want it in the center of the screen, but I honestly don't care, so we can get rid of those too. And then the window flags, which we'll just pass in 0 because we don't really care about those. And then let's also create a renderer. SDL create renderer. It takes in a window, so that's why we need to create the window first. And index, and it says we can pass -1 to initialize the first supported renderer. We're just going to pass -1 because that works out. And then there was one SDL renderer flag they suggested we use. No flags. Providing no flags gives priority to available SDL render accelerated renderers. So if we don't pass any flags, then we'll just use the accelerated renderer. So we can just use 0 for that too. So that'll create our window and our renderer. Next, let's look at our destructor. We're getting some bugs here because we no longer have free surfaces, we have textures. So if you want to free up textures, you call destroy texture. That's SDL create texture goes with SDL destroy texture. That's the way it is now. So now instead of freeing our screen, we need to destroy our window and destroy our renderer. We'll destroy our renderer first. So that way it kind of happens in a stack-like fashion. So we created our window and then our renderer. So we destroy our renderer, then our window. So whatever we created last, we destroy first. That's generally what I try to do. Also, our renderer depends on our window, so I don't know what happens with that, but that's just the way I'm going to do it. Yes, SDL set color key. I looked into this. It just wants SDL true instead of source color key. And then here we're trying to set our sprite sheets file path equal to image, which is a surface. So what we're going to do is we're going to reorganize this a little bit. So we're going to, after we've set the color key, we want to create a new texture, and this will be SDL create texture from surface, and the surface we're going to use is the image. And it needs to take in the renderer and the image. So let's pass in our renderer and our image. So what this does is it actually makes a copy of the image onto a new texture. So now we can free our surface because we're no longer using it. So let's call it SDL free surface, and we'll pass it the image. And the reason we want to make sure to do this part first is because it actually makes a copy. So if we were to set the color key of the image, Um, before we created the texture, I mean after we created the texture, so if it were like this instead, we would just still have all that black instead of transparent in. So yeah, so now it returns a surface ID, which is now a SDL texture pointer. So our blend surface is going to change actually quite a bit. So let's go into that now. First of all, SDL blend surface is not really a thing anymore. So we'll want to get rid of that. Instead, we're going to call SDL render copy. And this is essentially just, let's see what it says. It says copy a portion of the texture to the current rendering target. And so the main difference here is it actually cares about the width and height that you say in the destination rectangle. So if you pass null for the destination rectangle, you're going to fill up the entire screen, which is almost never what we want. So we're going to have to take care of that. So let's pass in our renderer. Our texture is going to be the source. And then our source rectangle is going to be the same. And our destination rectangle is going to be different. We're actually going to mutate it though, so it's not a problem. So there's a couple problems. First of all, most of the time we're not specifying what destination rectangle width and height should be, because before it just didn't matter. It didn't scale things at all. SDL didn't scale things. Blend surface doesn't scale things. Blend surface doesn't care about the width and height of the destination rectangle, but now we do care. And usually what we want to do is we want to match the source rectangle, but sometimes source rectangle could be null. So in that case, we want to match the SDL texture size. So what we're going to need to do is first of all see if we are past the source rectangle, we can just use the width and height from there. So let's just do that and worry about the else case in a second. So then we'll just say destination rectangle width is equal to source rectangle width. And the same thing for height. Now, if source rectangle is null, we're going to need to use the width and height of our texture. So there's a function to get the width and height, as well as a format and an access from our texture. And that is SDL query texture. So that is the function I'm going to use. And I was just Googling around to find that. I don't have any special knowledge. I just Googled it and found the answer in a random forum. So I can't even attribute it because I forget already. So we'll pass it the source. It wants a format. So uint 32t format, as well as int for access, width, and height. And we'll pass the address of these. So excuse me on that. Format, access, width, and height. All we care about there is the width and height, but we got to pass stuff for the other parameters. Otherwise, I mean, how are you going to call it, right? So let's assign our destination width and height from those. All right. What's next? Draw rect. Draw rect calls SDL fill rect. So what we actually want to do, what we want to do now is call SDL draw render fill rect. I believe is the name of it. Yes. So so that takes in SDL render fill rect takes in a renderer and a rect. And you're like, well, how do I color it? The SDL renderer has some state inside of it, and one of the pieces of state is the fill color. So we're going to have to actually set that before we call SDL renderer fill rect. But let's pass in the dest rect or a pointer to it. And set the color right before. So set render draw color. And this is how we set the draw color for the renderer. And all we do is pass the renderer an RGB. And RA, we'll just make it solid 255. Okay, finally, we're getting to the last two graphics things. The first one is clear. Before we were doing a fill rect, now it's actually a little bit more idiomatic, and it's SDL render clear, and passing it the renderer. And then here we do an SDL flip, and now it is SDL render present. I don't know where they got the name for render present. I guess you're gonna render whatever you have now. Maybe that's like present is now. I don't know. I kind of think it's a little bit of a weird nomenclature, but I don't really care that much because I'm done with it now, and I call it flip for the rest of my code anyway. So let's see. I'm gonna build, see if there are any bugs in. Well, I guess there will be bugs, but find out where they are. So sprite sheet is an SDL surface pointer. We actually need it to be an SDL texture now. So let's go to the definition of that. And call it an SDL texture. And F7 to build. Let's go back to sprite. Save F7 to build. Okay, so now the rest of the bugs seem like they're just in input. So let's jump over to input now. So like I said, the main thing with input is we're just going to switch over to these SDL scan codes, which is, I think, a really actually kind of a nice abstraction that is new. SDL scan code. And we'll jump to input CC so we can do it in there too. Oh, where are you? Oh, that was lucky. So we'll change all these SDL keys to SDL scan codes. And instead of getting the .sim, we'll want to get the .scan code. Oops. Oh well. And now we're mostly done with input. But I think we're at the point where we should be able to compile and... No, actually, we got to change... can change some other things. Wait, game CC. Yeah, so we're still using these SDLK enums in game. So let's switch these over to SDL scan code. And this is basically just going to be replacing SDLK underscore with SDL scan code underscore. But also everything should be capitalized too. So there's no SDL scan code X. It is now SDL scan code capital X. And I think that's all of them. Now we should be able to build and run, but we'll get some weird problems. Nope, a couple more of these, P and N. All right, build. Okay, F5, and yeah, so we get to, that works. But now I'm actually holding down the key Z, and we're getting our jump up and down. And what's the deal with that? Well, so SDL2 does things a little bit differently with its key repeat. It assumes you want key repeat, which we don't, but it's pretty easy to turn off. So if we go into our game CC, we can just say, where are we setting input? So we only are getting an input key down event if our event.key.repeat is false. So it's non-zero. See, it says it's non-zero if this is a key repeat. So we don't want to catch the key repeats. So if not. And so let's build and run this and see if that takes care of that problem. And then I also want to bring the collisions back in. So that took care of that problem. I want to bring the collisions back in so we can try the draw rect. Let's see, that was in debug draw. So let's see, debug draw. We'll just turn this on temporarily just to see if it is drawing the rectangles, and it is, and it looks like it's drawing fine. And so yeah, so that was the switch to SDL2. I think it went pretty smoothly. I mean, the hardest part is setting up library linkage and include directories in Visual Studio, but those of you using Windows or Linux and Mac, I'll update the make files so that you pretty much don't have to do anything, but you can look at the changes if you like. But yeah, that's, I think, all I wanted to cover today. So thanks for watching. Happy developing.